You guys are audible?
Yes, sir.
Yes, sir.
Yeah. So here it is about networking devices. Okay, networking devices. So here, which devices we are going to discuss is mainly hub, switches, router, modem, wireless access point, and Wi-Fi router. So detailed explanation is about hub, switches, routers. Okay, but you're going to see a small, quick points about these things. Then we'll go to the detailed explanation. Okay, hub. Hub is a networking device, right? It is used for LAN communication purpose, mainly used for small networks. Hub broadcast packets to every device in the network, all connected devices. You can also say a hub broadcast packets to all connected devices. Next, switch. Switch is also a networking device. Yeah, these are all networking devices. Switch used in the LAN communication. It is also used in LAN communication, but both small and large size of network means more number of devices we can connect to the switch. Switch in a starting, maybe initially it is broadcast packets to all devices. Two minutes, guys. Just wait 2 minutes. Okay. So, am I audible, guys?
Yes, sir.
Very good. Okay. The switch used in LAN communication for both small and large network. Switch initially broadcast, but later it is unicast using MAC address LAN with help of MAC address table. So switch learn the MAC address of devices. Only quick points only, just for quick points. Later I will explain. The next device is router. Router is used for both LAN and WAN communication. Both it will use in both LAN and WAN communication. Router is a inter-networking device. So router connects different networks. Router shows best path to reach the destination. Router shows best path to reach the destination. Next, modem. With using modem, you can help to connect to internet. So how you're connecting? your modem to your ISP, Internet Service Provider. Through that one, you are connected to Internet using telephone or fiber optical cable. So you will get Internet access. Wireless access point to connect wireless types of devices, wireless devices like your laptops or your desktop through wireless device you want to connect it. So we need a wireless access point. Wi-Fi router. The Wi-Fi router is to connect wireless devices to connect it to internet through integrated modem connectivity inside of your Wi-Fi router also there. And to connect between different networks, we can use Wi-Fi router. So these are the main networking devices. Other than that one, firewalls and other things also there. So if any possible, I will try explain this firewall also, maybe in this one or later. Let's see. Okay. Now one by one we'll see what is hub, what is switch, what is router explanation. This is how the hub is look like. You can also put it in a Google, that is networking hub. If you type hub, it will show differently. You can use networking hub. So these are a networking hub. Generally, these hubs are having small number of ports, like 6 ports, 8 ports hubs are there. 16 port hub, 24 port hubs also there. Okay. So you are connecting your devices to your hub. Then you created a network. So it does not understand anything about IP address or MAC address. Again, hub used for LAN communication, suitable for small networks. Hub, it broadcasts packets to every device in the network. For example, you connected devices to your hub and you are communicating from A to B. For example, A to B communication. A send packet to hub send packet to everyone. To B, C, D, E, F also. B accept the packet, remaining devices drop the packet. See? And hub is always broadcast. Not in a first time. It is always broadcast. Because of this broadcast, packet collisions are more and packet data loss is higher. And this hub comes under OSA model. In a OSA, as per OSA, it is layer 1 device. We can call hub is a layer 1 device. In a OSA model, it is physical layer. Okay, this is about your hub. Again, what is this? And then this configuration for some batch. Okay, so I'm using same configuration for you. Okay, instead of putting and connecting this, it take a lot of time to do all these things on that. Yes, this is a hub device. Of course, first, what is this? This is a Cisco packet tracer. It is a simulator from Cisco company. Okay, if you want to get this Cisco packet tracer, you have to go to NetAcad. What is this? NetAcad. NetAcad is a website. It's a Cisco academic website. It is. You have to go to NetAcad and create a login. I think I already logged in. That's it is searching for that login. Yes, I'm already logged in here. Okay. So my login account it is shown here. Okay. So you have to open NetAcad and so you have to create a login. I will show you here how to do that one. Okay. Just click on login. Then if you are not had login earlier, if you're not having a login earlier, so then you can just click on sign up. Then give your details. Okay. You give your details, account will be created. Once account is created, just log in. Okay. Once you log in, you can learn a lot of free courses from here also. If course is showing free, it means it is free course. Okay. So like different courses you can learn, cyber security like that. See, this is free. This is not free. This is free. Okay, free course. This is not a free course. Networking basic, hardware basics. Okay, like there's a lot of other things. AI fundamentals, data analytics and essentials, data science. These are all you can able to learn, which is having free. Okay. So from this site only, you can download this packet tracer or any other site also you can download it, but packet tracer belongs to Cisco. Okay. Once you download, install and open. Once you open this Cisco packet tracer, so first time you are open the Cisco packet tracer in that day, okay, it will show you a login kind of stuff like this. It will open like this. Yeah, like this it will show us. So click on this green one. Just click here. Once you click, it redirected to your default browser. In your browser, if you are already logged in like this, so then it will be automatically logged. So then you can able to access your packet tracer. Again, what is this packet tracer? It will provide different networking devices, including routers such as hubs, wireless access point, Wi-Fi routers, firewalls, IoT related devices also. You can do it. System, server, laptop, like that. To create a network or to simulate a network, maybe for your organization, you want to prepare one networking setup. So you can do that one here. You can create that network here and configure it, test it. If everything is fine, you can implement in a real systems. And is also very useful for learning. Okay, learning CCNA, Cisco certifications are there now. That is very useful. So this is packet tracer introduction. Okay. So what I'm done here, I've taken a hub. This is a hub. Double click on it. So this is a simple hub. It contains 6 ports. In this hub contains 6 ports right now. Okay. This is simple hubs. If you see the hub also, only configuration, nothing more. In the configuration also, only hub name only there, nothing. So I connected the systems. I connected system to that ports. Okay. Then I configured IP address into these systems. Okay. Now, if you want to test how they are communicating. So this is a simulation. So I want to check how these packets are sending and receiving from here PC0 to PC3. I want to test how it is packet is traveling. So this is a packet. See, source is 0.11, destination is 0.14. Step by step, first packet will send to the hub. Hub don't know where is the destination. It broadcasts the packets to all other devices. Other devices drop the packet. Destination accept the packet. Again, destination replying to the RPC0. The packet sent to the hub. Again, packet is sent to the packet is sent to all the devices except to the source, means from where it is generated. So these devices drop the packet and it is accept the packet. So communication is successful. Once again, so PC0 to PC1. Okay, see packet is sent, broadcast. Again, packet is sent, broadcast. Okay, is always broadcast. It does not know about what is a MAC address, IP address. Okay, it simply receive the packet and broadcast. This is hub. Guys, understand how hub is working?
Yes, sir.
Hub, again, it's used for LAN communication, suitable for small networks. Hub broadcast packets to every device in the network. If a device send a packet to other device, hub, the packet is sent to the hub, hub send packet to the all the devices in the network. And hub comes under layer 1 device in OSA model. It's a physical layer. Okay. Repeater. What is repeater? Repeater repeat the signal again. Normally, our UTP, STP cables we are using in the network. The maximum size, maximum length support is 100 meters. UTP, STP cables maximum length support is 100 meters. Okay. In case your next device is more than 100 meters, what to do? Around 100 meters, your signal becomes weaker. So at 80 meters, for example, you put a repeater. This repeater repeat the same signal again. Means with the same signal strength, we can able to send another 100 meters. We can use hub as a repeater, or you can use a separate repeater for that one. And these repeaters for these repeaters for UTP, STP cables, LAN communication repeaters. But in wireless, we have a repeaters. What is that? Wi-Fi extenders. In your hall, for example, you have Wi-Fi router, or maybe in a server room, or maybe in a one corner of the office, you have a Wi-Fi router installed. But you are in the separate room. Okay, in that room, in that location, you do not get a signal, or maybe you got a very weak signal. So then we have to place this Wi-Fi extenders in between this Wi-Fi router and your end user device. Okay, depends upon its coverage. The Wi-Fi extender must be inside the coverage of Wi-Fi router coverage, and your device must be in the coverage of your Wi-Fi extender coverage. In some organizations use multiple Wi-Fi extenders. Like in Savantis we use for every cube, every place we put a Wi-Fi extenders for getting good signal response. Okay, this is a repeater. Which device, where it use, that is also important. After hub, next device is switch. So switch used for LAN communication. Switch is used for small and large networks. Means large number of devices we can connect it. Okay. Switch maintains MAC address table. Switch LAN addresses of MAC address of connected devices. Switch understand MAC address. Switch learn the MAC address of connected devices, and switch maintain the MAC address table. This switch initially broadcast packets to every device in the network like a hub. But switch learn the MAC address of incoming packet and put that information into the MAC address table. So switch use this MAC address table to send the packet to the destinations. Okay. If you look at this MAC address table and the switch connectivity, can't we write on this one? Oh. Okay, if you look at this connection, A is connected to port number 1 and switch port is 2 is connected to D, like 3 is connected to B, 4 is connected to E, 7 is connected to C, 8 is connected to F. Okay, just connectivity. For a first time, this switch is on, For the first time, A try to communicate it to B. So A send a packet to switch. Which port number 1. Then what switch will do it? It take the incoming packet, their device MAC address, A's MAC address. You take this MAC address. Put that information into the switch MAC address table. In switch, there is a MAC address table. It put that information. This is A's MAC address and incoming port is port number 1. Okay, so A is connected to port number 1. What are the A is sending? That come to the switch through this port number 1 only. So for the switch, incoming packet is to the port number 1. That incoming packet's MAC address is A's MAC address, right? That information it will put it. Then it check what is the destination. Destination is B. Destination MAC address is B's MAC address. Is B's MAC address listed in the MAC address table or not? Is B's MAC address is there in the MAC address table or not? Yes. B's MAC address is available in MAC address table. It sent the packet to port number 3. Means packet directly sent to the port number 3. So B will get the packet. So it no need to broadcast. We'll take another example. C want to send a packet to D. C to D communication. C send a packet to the switch. Switch take the packet, check the incoming packet's MAC address, means C's MAC address, put that information into MAC address table and its port number. And C to D communication, right? So destination MAC address is D's system MAC address. It verifies MAC address table where is the D's MAC address. In case it is not found, in case it does not found that one, what it will do? It broadcasts the packet to everyone. Means the destination MAC address not found in the MAC address table, switch broadcast the packet to everyone. If destination MAC address find in the MAC address table, switch unicast the packet to the destination device to this destination device connected port number. Okay. So switch generally, initially, there is no MAC address table is constructed like this. This MAC address table is not there. Okay. So why this is showing very low color? Red color is better. So there is no MAC address table connected. Only table, empty table it is. Think like this, first time communication, A to B. Packet is sent to port number 1. Switch take the information. Incoming packets source MAC address is A's device MAC address. Which port packet is received? Port number 1. And what is the destination? Destination is B's MAC address. Destination B's MAC address. Okay. But in this MAC address table, there is no B's MAC address. What it will do? Switch broadcast packet to everyone. All the devices received a packet, they drop the packet. And B accept the packet. And B is now reply to A. So B send a packet to port number 3. Incoming packet, device MAC address, which port? Port number 3. Now what is the outgoing pack? What is the destination MAC address? A's MAC address. So switch check. Destination MAC address is there in the table or not? Yes, destination MAC address is A's MAC address connected to port number 1. It unicast to the port number 1. So it no need to send to everyone. Like the devices are communicating each other, that time this MAC address table is created and updated also. Okay. So like this, these are clear. We'll see in the simulation. This is a switch. Okay, this is a switch. To this switch, this look like this one in one side of the switch. This is second side of switch power cable. This is where we are connecting our devices to these ports only. It is 24 plus 2 port switches. 4 devices are connected. See the simulation. Packet is started from this PC to this PC. Means PC4 to PC5. Source is PC4, destination is PC5. Check the source IP, destination IP. Source MAC address, destination MAC address. Packet is sent to the switch. Now the switch will verify where is the destination device port number based on the destination MAC address. It send the packet to every device. Okay, this is the destination, so it accepts the packet, remaining drop the packet in broadcasting. Again, from BC5, packet is sending to switch to go to the PC4. PC4 receive directly. Why it is not broadcasting? Because switch knows where is PC. In the switch, I'm going to show you what is this MAC address, how it is look like. It is. This is the MAC address of a device which is connected to port number 1. This is MAC address of the device is connected to port number 2. Right now, only 2 devices are communicating, so it got those 2 devices MAC address on. In game, if I communicate from PC4 to PC5, no need to do a broadcast, but because the switch knows where is the destination. Okay, based on the MAC address table. If I'm trying to communicate to some other devices, so PC4 to PC7, so packet is sent to the switch, it broadcasts because switch does not know where is PC7. Okay. So switch initially broadcast, later it is unicast. Now again I'm checking 4 to 7. Now I don't require to do broadcast. This unicast. Of course, some different factors also there, but for now, for our understanding, this is the thing. And 7 is also communicated to us. 7 is also done communication, at least once communication. See, the 7th that's connected to port number, the 7th device MAC address it is. Okay, so this is called a MAC address table. Switch is used for LAN communication only. Okay, switch used for both small and large size of networks. Switch initially broadcast the packets to destination device. Later, it is unicast the packets with the help of MAC address table. Switch understand MAC address of connected devices, learn the MAC address of connected devices incoming packets, put that information in MAC address table. Switch maintain this MAC address table to unicast the packets. Because of this unicasting, so more number of collisions will be reduced. So then faster performance. Number of collisions will be lesser in switching. Of course, which comes under OSA model, layer to device, which is also called as layer to device. As per OSA model, it is data link layer. In switches, layer 3 switches also there called a multi-layer switches or layer 3 switches do the function like a router but without WAN communication. No WAN communication. You can use to communicate between different networks or inter-VLAN networking purpose. We can use it. Guys, understand switch? So what's the difference between hub and switch? This is important. Difference between hub and switch. Hub broadcast the packets to every device in the network. Switch unicast the packets to every device in the network. Switch usually broadcast, but later it is unicast. Okay. Sorry, first of all, difference between hub and switches. That's the main difference, of course. Switch hub does not understand MAC address or IP address. Switch understand MAC address. It learn the MAC address of connected devices and use MAC address table. Hub using LAN communications, which is also using LAN communication. Hub is suitable for small networks, switch used for both small and large networks also. Okay. Hub comes under layer 1 device. In a OSM model, it's a physical layer. Okay. Switch comes under layer 2 device. It is data link layer. Okay. Switch is a single broadcast domain, single collision domain. Switch is single broadcast domain, multi collision domain. It is. Each port is a collision port, but not entire switch because it use unicasting the packets. Okay. In a hub, we do not have MAC address table concept, but in a switch, we have a MAC address table concept. That's it. Guys, understand hub and switch? And do not worry about how to do all these things part. Okay. Just to understand, I am all created this thing for to show you kind of stuff. Nothing more. Okay. Just a minute, guys. I will put a charger to my laptop. Just a minute. Yeah, we start. Again, what is the next device? A router. So router is a inter-networking device. Router used for both LAN and WAN communication. Okay, router comes under layer 3 device in OSI network layer. Router works with a logical address. Here, our logical address is IP address. Okay, our logical address is IP address. The router communicate between different networks. That's what is called a inter-networking device. Next. This is main few points. And router means root. Router, router, root. Root means best path. Sorry, root means path, right? Root means path. So router shows best path to reach the destination. But how the router knows how to reach the destination? So routers having routing tables. With the help of these routing tables, router will tell you how to reach the destination. These routing tables are created by, we can create these routing tables manually. The routing tables are created manually. That is called static route. And these routing tables also can be created automatically using dynamic routing protocols. Using dynamic routing protocols. That is dynamic routing. What are the different dynamic routing protocols are RAP, AIGRP, OSPF, IGP, PGP kind of stuff. Okay. Dynamic routing protocol RAP, IGRP, EIGRP, OSPF, PGP. These are the main dynamic routing protocols. Once again, what is a router? Router is an internetworking device. It makes a communication or it connects between the different networks. Router used in both LAN and WAN communication purpose. In OSI, it's a layer 3 device. In a OSI model, it is a network layer. Next, router. Route means path. The router shows best path to reach the destination. Router having routing tables. These routing tables will tell you how to reach the destination. These routing tables are created manually, that is called static routing, or these routing tables in the router created automatically, called a dynamic routing. So with help of dynamic routing protocols, these dynamic routing tables are created. Routing tables are created manually, that is static routing. The routing tables can be created automatically, it's called dynamic routing. Dynamic routing protocols are RAP, IGRP, EIGRP, OSPF, BGP. Guys, understand what is a router? This is one logically and physically a network. This is another network. Both are in a different places. Now, these people in this network want to communicate to these people. How to make them? You have to make sure these routers are connected. Okay, I'm showing only two routers pattern. In reality, we have thousands of routers are connected. So think like this is your head office network. This is the branch office network. This office is connected to this using WAN connectivity. Okay. Through WAN, these networks are connected. In this scenario, this logically physically separate network. This is logically physically separate. So in this router, I'll configure a routing information. Okay. This is router show IP route. It will show the routing table. See, these networks are directly connected to your router. For this router, these networks 20.0.1.1 or 20.0.0.0, 192.168.1.0 networks are directly connected. So this router is not connected to this network. You can see 2.0, 2.1 network. Okay. It's not directly connected. But how I can reach from this device to this device, from 8 to 10, how can I communicate? Okay. By looking, see. So this router knows how to reach this network, 192.168.2 network. This router knows. How this router knows? Based on its routing table. This is the routing table. To reach this network, you have to send packet to this interface IP address. interface IP address. To reach this network, we have to cross one router. So you have to send the packet to here. Depends upon configuration inside. Written RAP configuration in these routers. Okay, don't worry. So if you want to communicate from this PC to this PC, okay, so you don't require this router. So you please send a packet to your switch. The switch will send packet to your destination. That's it. No need of router. But because both are in the same logical network. If this PC want to communicate to this PC, which is outside of my network, okay, which is outside of my network. This is 1.11, this is 2.11. So both are different networks. Packet sent to switch, switch send the packet to router. Now that router send a packet to another router. Other router verifies where is this network, send that packet to that network, and finally it reached the destination. Now PC10 received a packet, it's going to reply to the PC8. See, packet is sent to the router. Now router send packet to the destination. But it is failed for first time. But now once again, we'll see 8 to 210. Packet sent to the switch. Switch send a packet to router. The router send a packet to the next hop router, next router. That is check the and this network directly connected under it. It send the packet to that system. Again, it is send the packet to the router to reach PC8. This router now understand and send packet to this router. In both routers, we configure routing protocols to get the time. So finally, it is the destination. So router make a connect and communicate between different networks. Okay. Router and switch differences. Switch is used for LAN communication. Router used for LAN and WAN communication. Switch is to create a simple single LAN network purpose. Router used for to communicate between different networks. Switch use MAC address table to unique as the packet to forward the packet to destination. Switch use MAC address table. Router use routing tables. Switch automatically create these MAC address tables, but switch in router, these routing tables will be created manually or automatically also. Okay. So switch used for single network, router use between different networks. Switch comes under layer 2 device, switch comes under layer 3 devices. Okay, guys, understand switch and router differences?
So please tell once again, sir.
Okay. Router or both?
Switch and router
Switch and
difference.
router differences. Very good. Very good. That's one important part. So switch is used for LAN communication, LAN connectivity. Router used for both LAN and WAN communication. Okay. Switch is for single LAN communication. Router is in between different network communication. Means router make a communication between one network to another network. But switch is for only single network. Switch use MAC address table to forward their packet to destination. Forward packet to their destinations. Right? Switch router use routing tables. Router use routing table to forward their packet to their destination. Switch comes under layer 2 device. Router comes under layer 3 device. So router is an internetworking device, make a communication between different networks. Okay. Yeah, that's enough. The routing table
Okay,
switch use, yeah, the switch will show you the best path to reach the destination. That's a point. Good. I think few points are enough to remember. That's why I said few points. You can add more if you want. Very good. Modem, modulator, demodulator. So for example, to communicate between these two systems, both are in the same network physically, means you need a switch to connect these two devices and you can make them communicate each other. Both are in the same place. If destination is different place, different network, then we need a router to reach your destination. Because different physically, logically separate networks to communicate, you have to communicate through routers only. You want to connect internet. So you want to access internet wide available, like a google.com, facebook.com, youtube.com. Then what we need is a modem. Modem means modulator and demodulator. Okay. Example like a FM radio. So what are the voice is 20 to 20 kilohertz frequency. FM is high frequency modulation. It, okay, it will put your signal, voice signal into this FM signal, 88 megahertz to 108 megahertz. It can, what I'm saying, FM radio. So if you tune to FM radio, you decode it, you filter the actual frequency, you got the actual. But here it is a modem is like that. It's a modulator, demodulator. For sending modulation to receiving time, demodulation. Okay. The modem is generally used to connect to internet using telephone cable or fiber optical cable. Nowadays, Wi-Fi signals also you can use it to connect to your Wi-Fi router. Okay. That's it. So nothing more to tell about that. Okay. In our LAN network, our signal is a kind of digital form of signals. Separate signal. But now you are connected to internet, you have to send these packets data to so long range locations. Then modem converts as per the modem connectivity related signals. Media. Again, modem is connected to ISP. Through ISP, you are getting internet. Simple. Certain Wi-Fi routers as a built-in modem also there. Okay. We see other things. Wireless access point. This is wireless access point. I have two systems. This is wireless access. Okay. So this is the wireless SSID 21. I will change it to 24. When I change my SSID, automatically device will be disconnected. And I'm putting a password WPA2 PSK and password is admin123. Now these devices are unable to connect this wireless access point. How to connect it? Go to your wireless devices, configuration, set desktop, your wireless options, connected, refresh. Refresh. Why it is not pulling? Turn off it, turn on it. Again, desktop, wireless option, connect, refresh. Why it is not connecting? Yeah, sorry, it's in the simulation mode. That's why it is not getting settings. So connect, refresh. So still not showing. At least side other router is also there. Try on this one. Connect, refresh. Why it is? Yeah, now we got it. There is something, but not our router. Wireless access point. Yeah, turn on this one. SSID name H24. This is fast. Connect, refresh. What happened? Yeah, now we got something. Yeah, H24. Connect. Then give pass. So now it is connected. Of course, we have to configure IP address manually because this is the wireless access point only to connect wireless type of devices. And you have to go to the IP address configured properly. See that 13. Put IP address. Now test they can able to communicate each other. Yes, they are able to communicate each other. So how it is? Both are connected through a wireless access point. The last device is your Wi-Fi router. This Wi-Fi router contains everything. Itself, it is a router. See this internet port, which is connected to your ISP. From ISP, you got a cable. UTP cable from different types of ISPs like ACT. It's a UTP cable come to your home, right? In Airtel Geo, fiber optical cables are there. Depends upon that cable connectivity, you have to choose a router. And this router is a UTP cable type, internet point. And you see this yellow one are LAN ports, are for LAN port purpose. This is a configuration window. So simple to understand. So your Wi-Fi router to configure for getting internet. First is internet or WAN connectivity you have to do. Okay. Wireless IP, static IP, PPPoE. Hmm. So this is internet setup based on your ISP. Second, this is DHCP configuration. With the help of this DHCP configuration only, we are getting IP address. Wireless. In wireless, what is your wireless adapter connectivity name? SSID means wireless connection name. So I put a different names for different connection types. Also, security. Compulsory give password to your Wi-Fi router. AES is a higher level encryption type. Okay. So this is Wi-Fi router configuration. Separately, we can discuss it. See, there's a devices directly connected to your Wi-Fi router using wirelessly. And this is a device directly connected to your Wi-Fi router through cable. And you are getting internet through this English. Your Wi-Fi router, from Wi-Fi router, you are getting internet because Wi-Fi router, that's a modem part. Again, in our organizations, you are connecting like this. In small organizations, offices, more number of devices, but you find a Wi-Fi router to get connected internet, no problem. So what do it? So they take a multiple switches, connect all your desktop, laptop, other devices through cables, and connect these switches to your Wi-Fi router. Okay, this is Wi-Fi router. The Wi-Fi router is act like a switch hub. Okay, itself integrated modem. So next is it is act like a router. It's wireless access point to connect wireless type of devices. Also, it contains hub or switch type for LAN connectivity purposes. Your hub is your default gateway. When you are communicating outside of network, it is act like a gateway. DHCP server, local DNS server. So your router is also act like a DHCP server to assign IP address to its client devices when they are connected. This is about your okay. Guys, understand hub, switch, router, wireless access point, Wi-Fi router, and the modem and repeater. You understand up to here the networking devices?
Okay, sir.
Very good. Very good.